Welcome back to our Scala to Spark class, and today we will look at advanced analytics on basically machine learning support in Spark machine learning library. Okay, so yes, so what are we talking about in general is building some, getting some statistics and also building some models out of our data and trying to make some predictions. That's in general case, but there are many different aspects of machine learning. And you can divide these aspects in some big categories. There are different ways of classifying these categories. For example, you can have unsupervised learning and supervised learning, meaning unsupervised learning when you don't have any answers but you want to get some insights on data, maybe you want to segment the data. Unsupervised learning, which is what we'll be concentrating eventually today and during the rest of the week, is when you want to predict something knowing already some answers on existing data. You have some future data or some other data you want to have prediction on, and you want to use existing data to get answers. Maybe they are class-based, meaning they are category-based, maybe red, black, yes, no, is it a hot dog or not, right? Or regression-based when you want a quantitative answer, meaning a numeric answer. For example, you want to have a numeric answer knowing what the house price will be, knowing already existing house prices. We won't talk about reinforcement learning in this course, which is when you do, it's a very hot area of research, when you actually have the machine learning algorithm actually tries to learn rules, basically create some decisions upon some, maybe a reward function perhaps, right? Doing some learning tasks, maybe some navigation tasks, which are also a very interesting area, but we will focus on supervised learning mostly, with some emphasis on unsupervised learning. However, before we get started with all of the cool stuff in machine learning, actually the most of the work involved in machine learning, just like in data science in general or data engineering, is of course the actual preparation of data, of knowing what to learn, having the right data types and actually right data, cleaning data, of course separating data. And so that's actually the most of the time will be spent actually preparing data. So the book we've been using so far actually has multiple chapters for this. So notice we are skipping quite a few chapters. Again, Spark SQL, which we've been using already. Data sets, right, which is basically a more generic, remember data frame is a data set of specific types of rows. Right. So again, something you could read up if you have access to the book, but not really, maybe not as important at the moment. And also RDDs, which are the older, the actual data structure, basically data set underneath in a Spark engine. But again, this is how you used to work maybe 10 years ago, and you don't really need to jump down to RDDs as much in these days. An interesting area which we maybe cover a little bit is how to create a production application, of course, right? Knowing how to write code, but also how to package it, right? How to deploy Spark applications. We'll talk a little bit about that. And maybe also there's a streaming section, which is of course when you have data coming in, constantly incoming data. Right. Okay, but so we are covering the big section 6, chapter 24, which is on advanced analytics. And again, maybe some of these things you might think it's okay, maybe it's a little bit advanced, maybe it's not advanced enough, but the point is that also these skills here will apply also not only on some general machine learning, also apply in general data cleaning concepts which you may encounter in different areas. So the chapter 25, preprocessing and feature engineering, I think is quite important, because that applies to pretty much all other areas of working with data. Right, preprocessing is basically 80% of the work. Okay, so let's get a short primer. Right, again we saw the big picture here, right? So we'll talk about this. So what kind of workloads are supported by Spark, and also where to go for help. We'll be using, there's a quite nice documentation, ML guide here, Spark Apache org, right? It covers basically most of the basically everything what's available at the moment. In fact, it will be more features than in the book, because of course book was 4 years ago. Also notice RDD based APIs are actually in maintenance. So again, if you want to do work with older RDD based APIs, actually it is not, they are supported still, right? But if you have an older project you want to work on, but they are in maintenance, they will not be updated basically. Maybe some bug fixes will be applied. Okay, so again, let's go over the big picture. Right, so again, what's machine learning? Of course, statistics, data science. Again, they're related concepts. Of course, statistics is underneath everything. Of course, most statistical concepts are underneath, right? And let's look at a broad overview, right? Of processing your data. What's supervised learning, right? Unsupervised engines, right? And maybe we'll talk a little bit about the graph analytics and deep learning, but we won't cover it in this course. So, right. So this is there's so many different resources you can learn. This is basically a practical a resource. In this course, what we are going to do something. There's theoretical underpinnings, right? Those you want to learn more about this, why things happen, you will need to do some extra research. I can provide some extra books on that if you're interested in, right? So again, advanced analytics is basically, well, usually this means you try to create some insights on your data, but also you want to create some predictions or recommendations, right? So again, how to approach a machine learning project is, of course, depends what you want to do, right? So most common tasks will usually be supervised learning, right? So you want to predict something. You are given features. So when I say features, okay, you have a row of you have a data frame, let's say a data frame, which contains rows. Of course, then you have columns of attributes, features, we call them features here, and you have also a label. It could be a category label, red, black, white, black, 0, 1, true, false, yes, no, or it could be a quantitative answer, right? Again, this label, and that's what we are trying to predict, right? So that's supervised learning. So again, there are also recommendation engines which we want to suggest, for example, products to users based on some existing behavior. You could also say they could fall underneath the supervised learning. Depends how you picture this, right? The recommendation engines, well, let's say clustering, basically that's actually unsupervised learning in this case, right? So clustering, anomaly detection. So these are things we are trying to find something about data. We don't have any idea what's underneath, right? Classical example would be store purchases, like you have a loyalty card information from a supermarket wants to know what kind of customers are buying their items. Of course, they don't have all the private information, of course, but they want to segment this data and maybe send different flyers, for example, right? Of course, that's classical example, right? So then there's also, of course, more advanced things like with graph analytics tasks. Remember how we worked with Neo4j in working for checking, finding some patterns in a social network, whether with people, dogs, or computers, right? So, but again, so we will look. So this is we'll look at some of the big pictures. So there's some nice books here: Deep Learning, Introduction to Statistical Learning. But these are relatively, of course, are quite mathematical, right? ISL, ESL, DLB. There are other ones, right? So. Again, if you have access to book, these are quite good for deeper look. But again, you don't need to. One of the things which is maybe people with doctor's degrees in statistics are quite upset that a programmer, maybe even without a bachelor's degree, can do quite useful work. Machine learning is basically practical application of statistical principles. Basically, often it is just programming a black box, and that's what maybe sometimes makes us a little bit upset. Well, yeah, somebody who just starts doing things and he or she gets results, and they basically have a working something which gives value to a company, to yourself, and but without understanding, deep understanding. And of course it is a little bit maybe slightly philosophically speaking, how could that be? But again, these are the tools, modern tools. You don't know everything, you don't have to know everything about the coffee maker to make some good coffee, right? So again, same thing, and we don't have to know everything about driving a car engine to drive the car, right? Again, it's impossible to go very deep in this abstraction. So Spark, philosophically speaking, provides a quite nice an abstraction to using these very powerful tools of machine learning, right? So again, supervised learning. Now we go to our most common type of machine learning is to use historical data. We call dependent variables. We train a model and we try to predict, right? Again, you want to predict person's income based on age. That's a feature. And again, so of course this is a very simple, super simple model. There's also a famous saying, speaking of models, if I can find it, all models are wrong, right? And this is actually what I like to see, but maybe I can't find it. And where's my all models are wrong, right? But some models are useful. It's a very famous saying by a British statistician Box. So that's basically what's going on, right? All models we build, right, by definition they are approximation of real life, right? And in fact often what will be slightly maybe counterintuitive is that these models are not, they shouldn't be too precise, meaning they shouldn't fit your existing knowledge exactly. That's a big problem in machine learning, is that maybe models overfit to existing data too well and they don't generalize to new data, right? So that's one of those problems we have to solve when building a model, right? So again, you can create impressive accuracy when doing simple operations, right? But again, it's useless because it does not represent the reality, right? So again, you always need to know how badly the model can be wrong and still be useful, actually, right? So if you have again, pretty much any type of model, even could be quite wrong, but still have some use if it provides, use to people, basically, right? So let's keep going. And so yes, so classification is when we have an answer, a category, maybe some values, right? Like most extreme common case is binary, when you have yes, no, true, false, some right, email, is it spam or not, for example, right? You train an algorithm to analyze words and maybe some properties and make a prediction and maybe get, and hopefully this model again can give you answers whether it's a spam or not. Of course, when you have more and more two categories, you have multi-class classification, right? Maybe it's spam, personal, work-related, or other. You've probably seen this work in progress when you look your Gmail, right? It tries to classify the email. Spam, personal, maybe has like 4 or 5 categories, right? Maybe forums, and what else? There's updates, again in your Gmail inbox, right? They're using this multi-class classifier, right? So, of course, predicting disease, right? Of course, quite often used for classifying images, right? Quite, right? So, also, of course, is what kind of customer you have, right? You have some features about customer, like maybe how long they've been a customer, how much they buy, when was the last purchase, again, maybe how old they are, maybe their gender, again, right? Depends what you can use, but of course, what purpose you're using it. Again, I'm not going into ethics of what you can use and can't use. That's, of course, another big can of worms, so to say. Again, and depends how companies use this, but for example, it'd be completely, banks, for example, trying to give you a mortgage depending on your age, maybe, right? If you are 18, right, this model, it could be a useful model, right? The question is whether you're allowed to do an age discrimination. That's a good question, of course, right? Whether somebody who is 18 or somebody who is maybe 38 or 48 or maybe 78, right? So whether they should be getting a mortgage, for example, for their apartment, right? So, but yes, so predicting customer churn, whether they come back or not, whether they will buy or not, again, this is happening all the time. So the second task is, of course, is when we want to get regression, is we try to get a real number, right? Rather than predicting a category, we want to predict a value on a number line. Otherwise, the process is very, very similar, right? So again, they're both forms of supervised learning. Again, looking at the picture, the big picture here, right? It's this part here, right? This part here, right? Okay. So, right, predicting sales, predicting height, right? Predicting numbers of a show. Of course, Netflix is one of the biggest data science companies making all kinds of predictions. It's arguable whether their data science approach is, it's been working quite well, right? Maybe sometimes it just leads to relatively, bland shows, right? They try to appeal to the largest denominator, of course, right? So, maybe nothing too controversial, but okay, that's another story, of course, right? So, right, recommendation, right, you want to say, maybe you see what people have been buying, right, and of course Netflix, by the way, use Spark, right, it does use it to make recommendations, right, so this is like the famous case about 15 years ago, even before Spark, Netflix had a big competition, Netflix $1 million competition, Netflix $1 million challenge. It was very famous. It brought machine learning to $1 million, right? This is 13 years ago, right? That it was mostly then still DVD rental, right? So basically, idea was to create a new algorithm to predict to beat the Netflix own algorithm to predict user ratings, right? So idea was, this is actually, you didn't have any information about the users or films, right? So you just had numbers. You couldn't really tell what the user was. There's no personal information, right? So this is quite a hard challenge, actually, right? And you didn't also know what the movie is, right? You didn't know whether it's Batman 1 or Batman, which movie it is, basically. You did not know. And the funny thing about this prize, you can read about it, is that it was a big challenge, but the algorithm, right, it was actually too smart, right? It was, Netflix did not end up using it. They gave the $1 million prize, but they used something simpler, right? Because it got too, too crazy, right? So you basically got the triplets: user, movie, date of grade, right? So, and you had user, movie, basically, right? And you try to get you had a learning or qualifying data set, right? Right, and also, right, you had a training set, of course, which is what people were using to train. So in fact, this is a good example of a general, machine learning data science, challenge, basically, because you have a training set, right, and then you have a qualifying set, right? So you had a test set you could check, right, and this is for winners, and quiz set was for actually leaderboard scores. So the thing is, one of the key ideas here, which we'll talk about a lot in this section of machine learning, is that you have a separate training set, right, which is completely separate from a test set, right? That's the bare minimum that you will encounter in machine learning, challenges. You want to have some separate data, right? There are many ways, different ways of how do you divide this data, but basically this test data does not touch your training set, basically. That's often quite important. It's actually crucial, because otherwise you taint the training, basically, and again, these algorithms, they tend to overfit, and you will not get a useful model if you are checking your basically, if you already know the answer, basically it is what you're going to be testing. It's okay, you'll get good results, I mean, seemingly, right, but it won't be usable, right? Of course, this Netflix operation had 4 different data sets. You had training set, and basically this was a test set for those who are in the challenge, and then for determining winners you had test set, which was for real test set, so to say, right? And you also had a quiz set for leaderboard scores. But basically these 3 are basically same idea, except used for different purposes. Here this is for people who are in a challenge. This is for the actual winners who gets $1 million, and this was for the leaderboard up to the $1 million prize. Okay, right. So again, we'll talk about a little bit about this, about these challenges a little bit later. So let's see how much time we have, because again, I'm talking about mostly statistics here. right? Okay, so recommendation, right? Product recommendation, of course, Amazon, right? So we will talk about that in a little bit as well, hopefully, right? And unsupervised learning, right, is act of trying to find patterns when we don't have data. Again, so recommendations, well, you can think of it as a classifier, right? Or maybe you want to it could be a mixture of unsupervised or supervised. That of course also there are a mixture of different. You can divide these categories even more deeply. But for now, supervised, unsupervised is good enough, right? So unsupervised learning is maybe you want to know whether data is not fitting existing data, basically, right? Something like when some strange object is on your video screen, right? That's a good application. I had students who work on projects, for example, for determining whether you have your radio signal is giving you some strange anomaly. And of course, user segmentation again is when you want to cluster people by players or users by something, but you don't know what they are. Maybe people are casual players and hardcore players, for example, right? Something like that. And of course, things actually have quite a bit of experience is topic modeling. This is actually when you want to find, you want to cluster these. You have let's say pages, text. It could be a web page or maybe just books, documents in general, right? And you want to generate topics for these, right? So of course, the thing with unsupervised learning, at some point you have to have a human input, and you want to determine what's going on. Again, these are usually in supervised learning. These are just tools. They are not. They're not the end answer, basically, right? You still need a human. So you don't have to be afraid of machine learning replacing everything, right? They are just tools. They are helpful tools, but they can't make the final recommendation. And one of the problems, I'll talk philosophically, is that many of these high technology companies such as Google, Amazon, Facebook, and so on, they have taken out the human from this loop, right? And if you sometimes you have a rejection for something, and this is done by this machine learning algorithm, you don't have the human input anymore, and that leads to big problems because you will always have some false positives, right? Same as false negatives, but false positives, you have somebody says, okay, you should be banned from this service, right? And that's a big problem. If you have no human input and see, okay, this is not, it leads to sort of like a movie Brazil scenarios, right? When you are determined, or maybe 1984 scenarios, but more like Brazil, that or Kafka type of scenarios when you have very little recourse, right, with these services. So that's one thing you should remember, of course, that human is quite important in these scenarios. So, okay, but enough philosophy, right? So graph analytics is quite nice. We saw it in Neo4j, right? For example, fraud protection, right? Fraud networks, right? Also could be quite useful. I don't think you'll have time to look at the graph analytics in this course, but it's also available in Spark. So there's some advanced packages, right? So this is included, right? So again, there are other packages also in other libraries, in other different languages. For example, Python has scikit-learn, which is a very good library. So why should you use Spark one? Well, the answer is, of course, that it is for a single machine. It's just one of the tools. It's up to you. However, of course, is that Spark basically gives you for almost free the ability to scale if you need to work on larger data sets, right? This will be, Spark will let you do it, whether with other libraries, toolkits, it will be much harder to set up this parallel processing, right? So again, so you can write your regular code and then you will be able to scale quite easily, right? So, okay, of course, again, these are for, again, mostly we're talking about longer jobs, basically, right? For quicker jobs, you might need to do some custom work as well. Okay, so let's look at our, now that we have seen this philosophy, this big overview, let's see how the ML library, again, we're talking about the Spark, this library, right? Again, we have it already imported, right? So basically the idea is this: we have some data, maybe it's from database, like we just learned from data source, CSV, JSON, text, you name it, right? And then we perform some so-called pre-processing, cleaning, feature engineering. We create data ready to be processed, basically, right? This is called transformers estimators. We have clean data, and we can model depending on the kind of answers we want. And then we perform what's usually called cross-validation. We perform it on different test sets, right? Cross-validation usually means that we check, we run training, we split our data in training and test sets, and we test on all the data we have, basically, right? Each time changing our test set and our training set. But again, we'll talk about that as well. And then, of course, we have some metrics to say, okay, are we doing good? Because you need, of course, in your tuning, you need some metrics. And when you have success, of course, you have a working pipeline, right? So transformers. When somebody talks about transformers, basically this is function which basically transforms data in some way. Maybe a new variable, maybe a column is normalized, maybe you had numbers from 0 to 50, you want numbers from 0 to 1, real numbers, right? Maybe change data type. Again, that's also a transformation, right? So again, example would be transform string categories into numerical values. Say red, blue, you change to 0, 1. Right? Again, that would be a transformer, right? So feature engineering, right, and pre-processing. Okay, what else? Right, so standard data frame, standard transformer, input naming. Again, it's a transformer. Well, estimators are basically can be data, can be transformed, which is initializes data, right? And then maybe we'll need to change some data, right? Also, we also have evaluators, which let us know how the data model performs according to some criteria, right? Again, this is what we can use to change test or best models. Okay, so what else? So high level, so transformations, we specify these. So we basically build up a number of steps, right? And we basically add them into a pipeline. So this pipeline concept is quite common in machine learning and data science. So basically, these are instructions on what to do with your data, right? So that's one thing. Also, what else do you need to know? You need to know a little bit about some data types. There's a vector, special vector, machine learning vector, basically, right? So usually you need to do a vector, right? And there are basically two types of vectors, dense or sparse. Basically, if you have lots of zeros sometimes, right? No answers, right? Missing values, right? I would say null, not zero, right? Or dense, right? So usually, of course, it's much easier to work with dense vectors, right? So again, there are, but of course, they take more memory, right? So sparse is because when you have mostly zeros or missing values, you use sparse, right? So there's some examples. You can import from linear algebra vectors, and you create a vector, basically, right? Again, they're very identically, otherwise they're very similar as far as, data. It's just an array, basically, right, underneath, right? But they are more specialized for these machine learning applications, right? And you can create a vector. Again, I'll show you maybe. Again, we'll start with this example, right? Maybe something's very simple, right? Since we already have our machine learning, right? So we'll start something very simple. We finally get to the code today, right? We've been doing all this theory talk, and we need to talk about get some code. Of course, it's always nice to have some code. So new Scala class object, and we'll say day32 MLlib, right? Or MLlib, right? I'll call it like this. It's actually more like technically MLlib, right? ML intro. I'll call it intro maybe. Okay, ML intro. Like that. Extends app. Right, and we can see this here, right? Do we need Spark? Of course we do need Spark. Well, we don't even need Spark here at the moment, right? We didn't really do anything. Let's see this, right? So if I do this, right? Alright, so right. Low level data types, right? So this is something we might encounter. Right, and and this is basically just dense vector. We say what is. Let's see what happens here. So this will be red, of course, right? I don't have vectors. Import class, which one? Linear algebra vectors. What's the difference? ML, I think it's the same thing. I'll do this one. Yeah, it's the one, right? Linear algebra, right? Yeah, I believe it's actually the same one. So vectors, right? It's a special type. Yeah, right. So vectors, because of course, again, notice not to be confused, right? Not to be confused with Scala vector, right? Which is different, right? Right. But actually, performs some actually has, many similarities, of course. Right, it's a sequence. It is a sequence for one, right? Both are, at least, minimally they're both sequences, right? So, right. So dense, right? So other values. So 1, 2, 3, right? So let's say print, right? So print line, right? Let's see what happens, right? Let's run it. So here, right? And you can use, of course, regular methods, right? Let's see what happens. So dense means that actually it is. So usually, you see, it wants these to be doubles, because that's how machine learning works, right? So notice again, so print line, does it work? Compiles. I've been talking so much. Yeah, it works, right? So you can do also, I'm pretty sure you can do print line, dense vector, head, I believe. Yeah, you can do head. No, first, right? You can do to array, for example, right? Yeah, you can do to array, right? Right, to doubles, right? Doubles, my doubles, double array, well, are doubles, right? And of course, this is indeed array of doubles, right? And usual stuff, right? So of course, print line, are doubles, make string, something like, just the usual stuff, right? Basic stuff, we can always convert. We can convert to array when we need to. Okay, so simple stuff, right? Okay, so this is something again. So don't be again. It's basically specialized again. So why can't it use just regular array or vector? Because of course it is dense, because of this dense and vector and sparse support. Again, maybe we'll see an example, right? So right, so here, right, so this is an example how to do a sparse vector. Let's see how it works, right? So basically, you say you have values, arrays. So these are just give a size, right? And you give maybe, let me give you something crazier here, right? So sparse, right? So index, right? I'll do maybe 15, right? And I'll do array index maybe 10 and maybe 6 and maybe 9, right? And I'll do maybe some values, I don't know, 5.0, right? Okay, right? So 3 size array values, right? And so let's do print line sparse vector, right? And let's see again if I do this. So sparse. Well, doubles again will be of course sparse vector to array again, right? And we can do it again, print line are doubles again, make string, right? Again, basic stuff, right? And we can do this. Okay, so as you can imagine, what's going to happen, it's going to insert at place 2, 7, index second place, 7th place, and 10th place, right? And we insert some values there, right? Some some random values, right? 50 doesn't matter, right? Okay, so sparse vector. So this is useful for storing data when there are a lot of missing values. Like it's a specialized data type. And again, we should see a lot of zeros here, right? Let's see this idea. Yeah, as you can see, so 15. So basically the sparse vector, notice, so the regular dense vector is just like an array basically, right? So, but however with sparse vector, it tells you, okay, it's 15 elements. We have indexes 2, second element, 7th element and 10th element, and in actual represent, when you can go to a real array, you have, so it's secondary element, 7, so 0, 1, 2, 3, 4, 5, 6, right, is number 3 because it's index 6, right, starting from 0, right, and so on again. So 7, 8, 9 is 50, and so on. Okay, hope you now the idea of sparse vector is pretty apparent, right? So let me commit this. All right, let me commit this sparse vector. So sparse and dense vector. Right, commit and push. Okay, and we can keep going. Right, so ML, am I using correct one? Right, ML in algebra, right? Am I using correct one? Right, there's confusion. Oh, so I think I need to do this. This works same way actually, right? So mention this, right? Right, I'll mention this. Yeah, so this is a warning. That's why this is right. We usually want the data frame. So this is of course a historical sort of yeah, right. So ML, right? So yeah, again, it works of course here because we're not doing anything with the actual Spark, right? We're just doing it using it for the data sets here. Okay, so let's read some data. To read some data here, right? ML in action, right? So let's do this in action. Let's see, right? So we read JSON. Let's look at our data. Where is it? I have updated for you. You have it here, right? Resources it's called data simple ML, right here, I guess. And this, I think it's a JSON file. You can see lab good green value 1 value 2, right? Basic, again, remember multi-line JSON, right? We already know how to read it. So let's read that. Okay, of course I need Spark, right? So let me get Sparky. Let's get our Sparky again. So well, Spark, get Spark, right? Get Spark. Right, importing from mine, right? And of course now I need it for actually to see some action. So this will show you the values, right? So this will be sort of demonstration what's happening. Again, nothing, all you do, right? We'll just only show the 25 values of this. Again, this is something we learn about reading data sources. Okay, what happened? Oh yeah, of course, because I did not source resources, right? Of course, there's no such thing, right? Like this, right? Yeah, of course, right? So that should work. Okay, so it's loading. It should be okay. So we have our data. Now we see, okay, so basically ordered by value 2, so which is this one here, and it keeps going down. Actually, most of these are actually, the value 2 is pretty big, same, right, 14 something. Of course, this is fake data. We have a color is green, label is good or bad, value, again, we have a integer value, we have a floating point, double value, and we have a label also. So we will maybe want to predict whether it's whether color and values, right? We have basically label, and we have 3 features, right? So let's see. This will be again a big sort of big overview, right? So we want to say a classification model, right? So we want to say, okay, what is it? What kind of data we want to get answers, whether to predict, right? We want to predict whether it's good or bad, right? Labels good or bad, right? These are maybe company customer health, right? Right, health, of course, meaning maybe not maybe health as such, but maybe is it, you know, is a good customer or bad customer, right? So one of the thing is, so important point is that all the transformers will need most algorithms inputs that we need to prepare. We will need to have doubles. We'll have the answers. They have to be double types. On the vector, double will be features, right? So we will need to transform, right? We will need to transform, right? So this is very interesting how we're going to do it, right? And this is actually, we'll get to the formula transformers, right? We'll use something called R formula, right? Like this, right? So, and let's check our basic operators, basically, right? So this is again a new language for doing some basically for so the data manipulation, again, something to make it very easier to create new, you know, feature engineering. And it comes from the R formula. It comes, of course, those who are aware of, there is a programming language R, which is used for statistics. And again, so Spark took this syntax basically from the language. So it's actually kind of, those who only have some knowledge of R might be easier for you to work on it, right? But again, so idea is this: you have separate target and terms, concatenation, right? On remove term, right? And maybe there's interaction on maybe all columns except the target and the value. Again, so there's 1, 2, 3, 4, 5 these operators, right? So basically we will need to use this R formula, right? We create the formula and basically we say, so basically it is used to create new data, new columns. So let's take a look how it works, right? So quite well. Again, we'll have some time to do. I think we'll do this more in detail. So, right. So I think I did this feature engineering. Did I do all of it? Right. So basic. Oh, here we go. Okay, no, not there. You won't have to do this, maybe. Right. So our formula. Right, there are other ways of do, by the way, right? But our formula is, I think, is quite nice. So we'll get to this here. Okay, let's see if we can do this here. Will it work? Yeah. Okay. Let's make an example. Right. So we can do it here. So supervised, right? Of course. So we need to, right? So our formula, I need to import it, of course, here, right? And now I can do this. Right, so we say, again, these are just instructions, right? But we, of course, we want to next step, again, we'll get to fitting, right? So we need this R formula transformer, right, to our data, so to get the values for our columns, right? But our formula will automatically handle our categories, right? It needs to decide which columns are categorical, which are not. So we're going to call it fit, and this will return a training version of our transformer that we can use it to actually fit our data, right? So so not always so it looks like kind of double fit basically, right? So this is kind of interesting. So basically, right? So here, right? Okay, Control Z. All right. So this is not always, so not always do you, so basically this here, right? So this, in this step, our formula learns how to transform data, right? Again, so not always, this step is not always needed, but you have to look at the instructions. Sometimes, many of these transformations are needed, right? So this is R formula model. So it gives you an R formula model. So it generates a model of transformation, and then, only then do you actually create a fitted transform. And let's see the results. Again, I think this will be quite nice. So we will see quite nice results. So basically we'll have a transformation. So this is very cool. Again, if you don't use it every day, this syntax, of course, you will forget which one is which, symbol is which, but it's a very compact way of transforming columns. So again, the whole goal is to have a lab, right? Have separation of these values of what you want ready for ready for actually machine learning work. And again, not only in Spark and this ML library, in many other languages and frameworks, you do need the doubles, right? So you need to, again, the hardest work is actually getting the data ready for actually doing some analysis, right? So let's take a look what happens. Yes, it's still doing the fitting. Okay, so now what happened is we have our fitted RF model, right? That's a R formula model. We say transform my data frame. We already saw data frame is this here, right? This data. So what we did, what these instructions said, we need a label, right? And it found the label actually. So this is this label, right? Is this? It becomes this basically. Okay. So we say, okay, this column called lab is going to be our label. And notice how automatically this R formula model, it knows this has to be a label. So okay, it has two categories, good, bad, right? And it generates, I'll give you something, maybe I'll add something, I'll add a so category, okay? And you'll see it automatically picks up another new label 2.0, right? So let me go to data. I'll add something so, right? Good, bad. Let's do so, right? So. Right, of course it's binary. I think they're using a binary classificator, but so we'll see so, right? If I run it here, right? You see that should be number 2, probably 2. Again, the numbers are not important here, just a label. So that's one thing. Also, maybe I should have said that false. I should have said false, so you can see what's happening here. So basically, it also generated a sparse vector on saying where the answers are, right? And sparse vector of values on what the values are. We'll see what's happening here. Again, let's explore this also, this preparation of data. Again, it might seem a little bit magical, but actually nothing is further from truth. That actually it's quite logical. Okay, let's take a look again, see what we got. Right, top rows, that's our data, initial data. Now let's take a look. Do we have it too? Yes. So is automatically assigned to the answer, because of course you have 3 different answers, 0, 1, 2. Again, that's why, because models mostly want, computers like numbers, they don't like strings much. Okay, and now I expanded. So what happened here? So 1, 2, 3, 5, 8. So what's happening here? Basically this. It assigned the index of the values, right? So it generated, we did this color value on color value 2, right? Okay, so from color, right? So basically we have color with value 1. Looks like it created this colon. So basically in this index, if you check, right? So this is separate target and term. So target is what we want to find, right? And terms is what we need to do. So and then plus, right? So dot all columns except the target. So we go through all columns, right? And we say plus concatenate, right? So concatenate, we add. So we're gonna add these two. Or features are going to be color value 1, color value 2. And what is this? Interaction. So this is multiplication for numeric values or binarized categorical values. So what's happening here underneath? Let's take a look. So we have 1, 2, 3, 5, 8, right? So I think question is, do we always have 2, 3 or 1, 2, 3 or 2, 3? Not always, right? So why is that the case? I think because we're not using lab, we're using color value, right? And value 1 and value 2, right? So we did and we see the answers here again. So 1, 2, 3, 4, 5, right? Always, so sometimes only 4, right? Again, we'll explore this more in detail, but again, it basically generated a sparse vector of values. It's possible, again, 38, right? Yeah, 15, right? We see the values here. So yeah, it generates 15, 38, 15, 38 again, right? So if you look at the color value 1, color value 2, right? So again, not maybe not completely apparent what happened here, but we got a vector of features basically. And again, it's ready to work again. So it's relatively complex example. Again, I'll get rid of this good. I don't want to break the. I guess this is bad, right? This is bad. Let's see. Do we have time to look at our answer, right? Yeah. So we'll need to also split our data. Yeah, so next we'll do a split, right? So again, a very important set, and that's actually what we'll do is actually our main set, or today's work will be generating a test split. We'll generate a test split, and this will be quite important. So, right, so this is, so now the next to today's last set is to actually create a test set. So we want to split our data in two sets. So we want to split our data into a test and training, into a training and test set, right? So we can use something called random split, for example, right, for now, right? And we'll have an array of two, train and test, right? And basically this is gonna be, right? So 70% to 30%. Common is 70 to 90% training set, and then 30 to 10% test. Yeah, again, idea is that the sets are separate, right? Again, less overfitting, right? Very important set, of course. And then we can see, of course, we can say it's random split, of course, right? We're using data frame random split option, I remember, right? And we have weights, right? On it's already should be basically, we can see train, describe maybe, right? Describe, show, right? On test, describe, show, oops, describe, show. Okay, that should be. With that, we will be able to conclude our preparation of our data. Okay, our data is ready, and we can see, of course, so 31 and 79. So yes, again, remember, this is not completely hard-coded, right? So roughly 70-30%, but not exact. Again, remember that, right? So you can see how the data is you can see some specific ideas out of this summary. Okay, so that concludes our first part. There will be also an exercise, nothing too complex for that, but we'll continue later on.